We're going to find the magic number to complete the square. I'll talk about the magic number in a minute. Right now I just want to know, what does completing the square mean? So to think about this, I'm going to look at a review problem from the past, one of the past chapters. What is x plus 3 quantity squared? I'm going to expand that or multiply that. And if you remember, x plus 3, if I have a binomial and I'm squaring that, which is what we're trying to do, we're going to go backwards with this to complete the square, is you have to use FOIL because it's x plus 3 times x plus 3. Product of two binomials is FOIL, so we got to go do the first, then the outer, the inner. Whoops, I made a mistake. Sorry. That's a 3. The inner, to get at the answer, and the last. So you're going to combine the two inner parts, and that would be the answer. So if I look at this, we're going to try to go backwards here, and we have a 6. I'm saying, what number completes the square? Well, it's half of 6 is that number there. And then to get the 9, you square it. So let's look at that and try to go backwards. So let's now complete the square by looking at our first example. So this example asks you to complete the square by adding an appropriate constant and write the result as the square of the binomial. So adding that perfect constant right here, that is what I'm calling the magic number. We have to find a magic number that makes this a perfect square. Now, we are not yet using this. We are just trying to find the magic number. This is an example of just practicing the magic number. So what is the magic number? Well, I can see to the right is 9. So how did I get that again? I'm going to take 1/2, that 6, that middle term number right there, and I'm going to square it. So we get 1/2 of 6, which is 3. 3 squared is 9. So in this case, the magic number is 9, which is what this number was right here. If you notice, now you can factor this to be x and x, 3 and 3. It made this trinomial a perfect square. Let's try another one. So what is the magic number if you have a 10x there? So I'm going to go plus what? Try to find the magic number. What would it be? Well, it's going to be 25. How did I get 25? I took 1/2 of the 10 and I squared it. 5 squared is 25. Let's see if it worked. Does that factor now? Right? It has to complete the square by adding an appropriate constant and write the result of a square binomial. That's x and x. Factoring again. That's 5 and 5 to make 25. And the outer and the inner does make 10x. So that would be equal to x plus 5 squared. That one doesn't work. So the magic number for the second one is 25. What if it's an odd number? What number do we add now? Well, you're going to take 1/2 of -5, that over 1, and square it. That's -5 over 2. Squaring that is 25 over 4. So 25 over 4 is the magic number. And you might think, wow, that's hard to factor. But it turns out not to be, because this would be an x and an x, right? 25 over 4 to make, that's going to be the same, so it has to be the square root, so that would be 5 over 2, 5 over 2. And this is minus, so you're going to end up with a negative and a negative to make a negative 5x over 2, another negative 5x over 2, which is negative 10x over 2, which is actually negative 5. So the answer, or the perfect square, the square of a binomial, would be that. These are all just the magic numbers, so let me separate those like that. And that's how you find the magic number. So let's look at a second example. So let's look at our second example. we're going to use the completing the square now. So we're going to solve x squared minus 4x minus 1 equals 0 by completing the square. First, you notice you cannot factor this. So completing the square is great because you can solve equations now that do not factor. So let's go ahead and do this. The first thing we're going to do is we want to get rid of that 1 because we want to complete the square. So I'm going to add 1 to both sides. I'm going to put a space. So I want to complete the square. And whatever, I don't want to change the equation. So whatever I add on the left, I add on the right. And now we're going to find our magic number. So what's our magic number? We write it in this case. Magic number. It's going to be 1/2 the middle term squared. So what would that be? 1/2 of -4 is -2. And square it, you get 4. So 4, believe it or not, is our magic number. The only thing different I'm doing in example 2 than example 1 is I don't want to change the solution, and we learned that we can add 4 on both sides. So I'm adding that magic number to both sides so that the left side is now a perfect square. We can factor that to x minus 2 times x minus 2, which is x minus 2 quantity squared. We just made that a perfect square. That one we'll just add a 5. Why did we do this? Because now we can solve it by taking the square root of both sides and use that square root property that was in the beginning of the section. So let's go ahead and do that. Let me rewrite it. And let's take the square root of left and the square root of the right. Remember, when you take the square root of both sides, you have to add a little plus or minus. So the left side is just an x minus 2. And the right is plus or minus square root of 5. Finally, we can add 2 to both sides to solve for x. So now we have just solved for x. We've got an x on one side. If you want to get a decimal, you can do so by figuring that out in your calculator and rounding it. But that would be a fine answer. X is equal to 2 plus or minus the square root of 5. So we just use completing the square to solve a quadratic equation. You can also use completing the square in many other applications, like for instance finding the vertex form. In the section before, they actually asked you to find the vertex form with completing by completing the square, and you can do that also. When you do the vertex form, instead of adding 4 to both sides, you're going to add 4 and subtract 4 to the same side. So whatever the technique is, finding the magic number is completing the square. So let's write down a formula for that. What's the formula? Oops, formula. To find the magic number to x squared plus bx, you take 1/2 of that middle term and you square it. That is going to be the magic number. Let me do one more example. The reason I'm doing one more example is because when you have a number, notice how I didn't have a number in front of the x squared. It does make it a bit trickier because how are you going to complete the square with a 2 there? You'll have one factor as a 2x and the other as an x. And they have to be exactly the same. So to complete the square when you have a number, you need to somehow get rid of that 2. Sometimes they factor out the 2. Sometimes they divide the 2. If you have an equation, it's easiest to divide the 2. So that's what we're going to do here. So we're going to get rid of that 5 the same way we did previously by adding 5 to both sides. And I'm going to divide everything by 2. So I end up with, let's do it over here, x squared minus 3x equals 5 over 2. And I'm going to put a space because I want to add my magic number. So again, this magic number is odd, but we can find it just easy. It is going to be 1/2 of that -3 squared. That is the magic number. That is -3 over 2 squared, which equals 9 over 4. That is the magic number. Okay, so that is what I'm going to add to both sides. If I do it to the left and do it to the right, it does not change the equation or the solution. The left side is easier than you think again, because that's going to be an x and an x. See, when there was a 2 there, one of those would have been a 2x. And then this is going to be the square root, so that'd be 3 over 2, 3 over 2, and both would be negative to make that negative 3x. So the left side is going to be x minus 3 halves squared. And the right side, we're just going to get an LCD, so we make it 4. I have to multiply top and bottom by 2 in the first fraction. That would be 10 fourths plus 9 fourths is 19 fourths. We've just completed the square. So now we can use the square root property, extraction of roots. We can take the square root of the left, we'll do it in a different color, square root of the right, add a plus or minus. So the left side would be x minus 3 halves. The right side, I'm just going to leave. And then you can add 3 over 2 to both sides. This would be a perfect answer, but the computer does like you to simplify. So what they do is they say, well, square root of 4, we learned in a chapter before that that is a 2. So they take that out. And then they put this usually in one fraction. And that should be the answer. That's a 19. And you can get the decimal approximation for this, but when they it's not a word problem attached and they don't ask you to estimate, this is the answer the computer expects. So that is another example of completing the square. Hope that helps.